Right, question 22 from the May 2019 paper 1 for the International GCSE. This question is a properly complicated one, but there are little techniques that you can use. It's not actually difficult, it's complicated. Let me go through what I mean. First part says draw on the grid the graph of y equals 2 sine x plus 30. So what I suggest you do is think about the table function on your calculator. Okay, f of x this time is going to be 2 sine brackets x plus 30. All right. Oops, I've gone a little bit wrong there. Bear with me. Okay. So, where do we start? Well, we need to start at 0. We need to end at 360. And I got that information from looking at the chart, the graph that they've given me. And the step would be sensible to choose 30 this time so that we can get each spot. Now it's going to calculate and work out some of these places for me, and I'm going to mark them on. I get 0, 1. I get 31.732. I get 60 and 2. I'm going to go through and I'm going to mark on the points. 120 and 1. 150 and 0. 210 and minus 1.72. 240 and oops, it's very annoying that it keeps doing that. I've lost the question entirely. Sorry. 240 and minus 2. That's there. We've got 180 and minus 1. We've got 300 and minus 1. And 330, 0. And 360 is 1. And I'm simply going to join those up using a smooth curve. Now, this is probably not the way that they intend you to do this question. I believe that this question is testing whether you can translate graphs. You can understand what timesing and dividing does. But we have an alternative method for this question, and we've completed it. Right. Part B has absolutely nothing to do with Part A. Let's crack on. This is a question that we can do because we know how to do completing the square. We should be recognising this as a completing the square question. So we want x minus 3 all squared minus 9, because 3 squared is 9, plus 10. And simplify that. X minus 3 all squared minus 1. Where did I get the 3 from? Where does minus 3 come from? Well, hopefully you're all thinking back and remembering that we take the half of that value when we're doing completing the square. As long as the x squared value is 1, we can just take the half of the x value, the coefficient of x, and get that answer. Okay, hence is an important word here. The hence, it means using what you know up there. And it says, describe the single transformation that maps the curve. Right, there are 2 marks available here. And the first mark is just for remembering to say translation. When we do anything on these, any of these kind of things, it's usually a translation. So good guess. And what's happened here is that the thing has moved 3 squares across and 1 square down. So we can just write that. We can write translation 3 squares right and 1 square down. Now that's a lot of memory stuff that we'd have to do work here, and that might be something that we're struggling with. We have to remember that things inside the brackets only affect the x, so only move horizontally, and they go in kind of the opposite direction that you'd expect, whereas things outside the brackets only affect the y values, and they do exactly what you expect. All right, hopefully that's enough, and if you have other questions, you'll come back to me.